Hello, this is Professor Kuehn, and welcome back to my lectures on astronomy, where we're looking at the work of Galileo Galilei, his starry messenger. In my last couple of lectures, we went through some of the biographical notes on Galileo, which are included in Chapter 18 in A Student's Guide to the Great Physics Texts, Volume 1. We also went through his introduction, his dedication to the Duke of Tuscany, Cosimo Medici, and then we talked about his introductory comments and how he built his telescope. That was on page 230, page 231, and page 232. Next, on page 233, we gave a brief introduction to what his observations were when he turned his telescope to study the features on the moon. So let me remind you of some of the important things. He said, let me speak first of the surface of the moon that is turned toward us. And then he goes on to mention that there are mountains and valleys. And I'd highly recommend you read through this. His language is extremely colorful in describing what he sees, and these drawings that he makes are very revealing of the kind of features he's going to see on the moon. I just want to point out a couple of things. He mentions, first of all, that when you look at the moon, there are these large, bright and dark regions. He calls these great or ancient spots, and everyone's aware of these. If you go out and look at the moon, you'll see these bright and dark regions. But in addition to that, there are these very small bright and dark spots that are only visible if you look at the moon through a telescope, such as the one that Galileo was able to build. And he mentions that these look just like mountains and valleys on the Earth. How do you know that these look like mountains and valleys on the Earth? Well, it's because as the sun and the moon change their relative position compared to each other, that these shadows grow or shrink in size. So, in other words, as the sun illuminates more and more of the moon, that the shadows that had been very long get shorter and shorter and shorter. It's almost like if you've ever been in a place like a valley during sunrise, as the sun rises, you see, first of all, the sun illuminates the very tops, the peaks of the mountains, and as the sun gets higher and higher, the bright orange color that's illuminating the tops of the mountains creeps down the mountains until it finally illuminates the valleys. That's exactly what Galileo says appears to be happening on the moon as the sun rises compared to the moon. So that's something he points out. He describes this in some detail on page 234, and on page 235 he mentions, interestingly, that the Pythagoreans believed that the moon was much like the Earth. He says, here and there are some spaces, rather brighter than the rest, they crop up. He says, thus, if anyone wishes to revive the old opinion of the Pythagoreans that the moon is another Earth, so to speak, the brighter portions may very fitly represent the surface of the land, and the darker the expanse of the water. So he's even speculating about the idea that the dark regions of the moon may even contain water. He also points out on page 236 and 237 with these drawings and the text that there is an enormous crater that is facing us on our side of the moon. There's another point that he makes on page 238 that I'd like to draw your attention to. He says, here I feel that some people may be troubled with grave doubt and perhaps seized with a difficulty so serious as to compel them to feel uncertain about the conclusion just explained and supported by so many phenomena. So in other words, he's been talking about how there are these mountains and valleys on the moon, but there's a problem, and he's going to mention that. He says, for if that part of the moon's surface which reflects the sun rays most brightly is full of innumerable sinuosities, protuberances, and cavities, why does the outer edge looking toward the west when the moon is waxing, and the other half circumference looking toward the east when the moon is waning, and the whole circle at full moon appear not uneven, rugged, and irregular, but perfectly round and circular, as sharply defined as if marked out with a compass, and without the indentation of any protuberances or cavities? What is he getting at here? Well, you've probably noticed that if you go outside and you look at the moon, what do you see when you look at the moon? Well, you see a very sharply defined circle, almost like it was cut out with a cookie cutter. And he's saying, if in fact the moon has all these mountains and valleys on it, shouldn't we see kind of these bumps along the edges? mountains. But we don't see those. We see the moon as if it's perfectly round. So what would be the cause for this perfect roundness if in fact Galileo is right about the geographical features on the moon? And he offers two solutions to this. So here's the problem. Why is the outer edge of the moon smooth if it is in fact bumpy due to mountains? So why does it appear smooth if it is in fact bumpy? Okay, so that's a problem. And he comes up with a couple of solutions, and you can decide whether you think that these are plausible. So one of the solutions he gives is on the long paragraph on page 238, he says the first solution I offer is this. And then he goes on to explain how if you are, for example, driving toward the mountain, so imagine you're driving across the Great Plains in the United States and you're driving toward the Rocky Mountains. What do you see as you're driving toward the mountains? Well, it's true that you'll see the mountains rising on the horizon. I'm drawing a few mountains like this. But is that all that you see? Well, not exactly, because there are mountains behind those mountains, right? So it looks more like this. And there are mountains behind those mountains, like this. And mountains behind those mountains. And as a result, you end up seeing something that looks, for all intents and purposes, like a very flat horizon, even though there are mountains on the horizon. And that's because you're seeing not just one plane of mountains at one depth, but mountains behind mountains behind mountains. And so you end up getting a very flat looking horizon. He says that is an explanation of why the moon might look smooth, because in fact, yes, you do have these mountains, but you have mountains behind mountains behind mountains, and that gives rise to a very smooth looking surface of the moon. He explains it also in terms of waves on the ocean. If you're ever on the ocean, we know that waves are bumpy, right? So there's waves that are crashing, the surface of the water is very rough, and yet if you look at the horizon, it looks very smooth for a similar kind of reason. There's waves beyond waves beyond waves, and that gives the appearance of smoothness. There's another explanation that he offers. I'll call this solution 2, and this is at the bottom of page 238, and this is also showed in an image on the top of page 239. He says it's possible that the moon has an atmosphere. So in addition to the moon looking like this, it's got some thin atmosphere, much like the atmosphere of the Earth. And that atmosphere kind of offers a blurring effect. So if there are any unevenness on the surface of the moon, that unevenness would be blurred by the atmospheric effects. So those are the two reasons he gives for why the moon, despite it being actually bumpy, might appear smooth. Now, what else does he talk about? There's something very interesting and perhaps a little bit complicated that is at the bottom of page 239 and the top of page 240. And interestingly, what Galileo is able to do is he was actually able to measure the height of the highest mountain that he was able to find on the surface of the moon. This is very interesting because, of course, Galileo doesn't go to the moon, yet simply by looking at the moon through his telescope, he is able to determine the height of one of the mountains on the moon. And he says that it's about 4 or 5 miles high. So in my next lecture, I'm going to talk a little bit about how he is able to carry out this measurement.